Hello everyone, welcome back to the Blue Team training series brought to you by Hackersploit and Linode. In this video, we'll be taking a look at Docker image analysis with Trivy, more specifically the process of scanning Docker images for vulnerabilities with Trivy. So in regards to what we'll be covering, we'll firstly get an understanding as to why vulnerability scanning for Docker images is so important. We'll also get an introduction to Trivy. And finally, during the practical demonstration, we'll take a look at how to scan Docker images for vulnerabilities and misconfigurations with Trivy. In relation or in regards to the actual prerequisites, you need to have a basic familiarity with Docker and the Docker CLI commands, because we're going to be interacting with Docker containers. And of course, you need to have familiarity with Linux and various command line utilities, because we're going to be utilizing Docker on Linux. If you're new to Docker and Docker security, then please do take a look at the actual Docker security series that we actually did with Linode. The link to that will be added as a resource to this video, where we covered the process of securing Docker from the ground up. With that being said, let's get an understanding as to why vulnerability scanning for Docker images is very important. All right, so let's understand the process first. So Docker vulnerability scanning is the process of identifying security vulnerabilities for the packages that are utilized in a Docker image. So whenever you're creating a Docker container, the Docker container is created from a Docker image, right? And the Docker image is essentially made up of a Docker file. The Docker file essentially is a file that contains commands and allows you to configure what your image, what packages you want your image to run on. So you could specify you want your image to utilize Ubuntu 18.04 as a base, and then you can essentially add in additional configurations based on what you want your image to do when it is run as a container. So we're essentially looking for security vulnerabilities and misconfigurations in the packages utilized within the Docker image, because if I utilize Ubuntu 18.04 as a base, the packages included with that particular image, that base image, might be vulnerable to vulnerabilities, and if they are, then an attacker could potentially exploit that package and gain access to that Docker container, and they could then perform pretty much whatever or perform or do pretty much whatever they wanted to do within that Docker container. So this process will allow you to detect vulnerabilities in images before deploying or running them. So with the advent or with the rise of Docker in terms of popularity and deployment, Docker and containers and container security needs to be taken much more seriously. And as I said, if you are an organization and you're building your own Docker images, then this is something that you should include within that workflow. So whenever you've built a Docker image, always perform a vulnerability scan on it. So, once you've identified these vulnerabilities, the vulnerabilities can then be patched or fixed in order to make the image as secure as possible. This is a very important aspect of Docker security, primarily because all the security measures we have implemented on the host system, can be usurped by a single vulnerability in one of the packages. So again, just because you've secured the operating system where you have Docker running on, that isn't the end of security with relation to Docker. And of course, this is primarily going to be focused on, image and container security. With that being said, let's get an introduction to Trivy. Trivy is the tool we're going to be using to perform these scans. So Trivy is a simple and comprehensive scanner for vulnerabilities in container images, file systems, and Git repositories, as well as for configuration issues. So it's not just limited to scanning container images. It can also be used to scan for misconfigurations and vulnerabilities in file systems, Git repos, etc. So it's a very, very useful tool in that sense. Trivy can be used to scan infrastructure as code or IAC files such as Terraform, Dockerfile, and Kubernetes to detect potential configuration issues that expose your deployments to the risk of attack. We can utilize Trivy to scan Docker files for misconfigurations and vulnerabilities that could potentially lead to exploitation or data exposure. So the objective here is, to essentially scan a particular Docker file, or in this case, we'll be scanning the images themselves with Trivy to identify misconfigurations that can then be fixed within the original Docker file from which that image was built from. So let's get started with the practical demonstration. As for the lab environment, I've set up a server on Linode. It's a simple Ubuntu 18.04 server with Docker already installed, and that's where we're going to be running all of these checks. So let me just switch over to my Ubuntu VM. All right, so I'm back on my Ubuntu VM, and you can see I've created a Ubuntu server called Docker host, and it doesn't really have anything running on it. The only thing I've done is install Docker and essentially enable the service and start it just to make sure that Docker is running. As I said, we're going to be utilizing Trivy. So this is the Trivy GitHub repository. All the links are mentioned within this video are going to be added as a resource for this video, so don't worry about that. Trivy is created by a company called Aquasec. As you can see, the description is fairly simple here. Scanner for vulnerabilities in container images, file systems, and Git repositories, as well as for configuration issues. And then it provides you with a really, really cool ASCII video here, or just a simple screen capture as to how you can scan for vulnerabilities in container images here, as well as scanning for misconfigurations in IAC files. And of course, it gives you a quick start in regards to how you can utilize it. So in the context of Docker, you can see that right over here, as it says here, scan directory for misconfigurations, simply specify directory containing the IAC files such as Terraform and Docker files. So in this case, you'd need the Trivy binary, and you can easily install the Trivy binary. However, in this case, because we're primarily focused on Docker images, if we take a look at the Trivy documentation, you can see that we can scan Docker images using the following syntax. And if we click on vulnerability detection, you can see that we can essentially check for vulnerabilities in OS packages. So in order to do this, we're going to be utilizing the Trivy Docker image here. So let me just refresh that. For some reason, the images aren't being displayed, which is, I think that's fine, but let me just disable my ad blocker here. And let's refresh the page just to see, or just to make sure that that is the case. All right, so we'll be utilizing the actual Trivy image here. So there we are. You can see a simple and comprehensive vulnerability scanner for containers. So what we're going to do here is we take a look at the documentation. You can see that the features it provides us with here. So detect comprehensive vulnerabilities in operating system packages. And, we can easily go through this, right? So, you can take a look at the installation instructions here for Trivy. So, we can essentially add the actual source here, and we can then install Trivy. But as I said, we're going to be using the Docker image. So I will just pull this Docker image on my Docker host here. So I've already logged into the server. So I'll say Docker pull, and it's going to pull the latest image there. And we'll give that a couple of seconds. Once that is done, we can actually get started with the scan. So now the objective would be to identify an image that you'd like to scan for misconfigurations. It could be a local image that you created yourself, or you can essentially perform a scan on some of the other ones here. So for example, we'll be using this vulnerable image in a couple of seconds, but we can scan for vulnerabilities in any other images. So I can search for let's see, we can search for maybe one of my own. So let's see if I can find some of my own images here. So for example, the bug bounty toolkit, I think that will actually be too large to perform this, but we can search for the ones I created. I know I did create a log4j one. We can actually scan this one here. So for every Docker image, there's going to be a Docker file, right? So, we can click on the latest release there, and you can see that this is essentially the Docker file there. So what we can do is if we wanted to scan this particular image, I can essentially just copy the name here. So, I can just say hackexploit bwap docker. That's just a simple image that allows you to spin up an instance of the extremely buggy web application. So in order to do this, we're going to say docker run, and we're going to remove this when we're done. And we are going to say, we want to run Trivy. So Trivy, and that is going to be, we are going to specify the cache directory here, which we need to when running Trivy. So root, and we can just say cache. There we are. And we then specify the actual Trivy image that we pulled. So aquasec Trivy, and then specify the actual image we would like to scan. So in this case, hackexploit bwap docker, hit enter. In this case, it doesn't look like that is going to allow us to do that. So let me see if we need to change anything here. Can we actually scan Ubuntu? So I'm going to say Ubuntu, let's try 18.04 here. Do we need to get that? So pull, docker pull, not soccer. We want to type in docker pull Ubuntu 18.04. Does it need to be local first? I think it does need to be local. So yes, you actually need to pull the image and have it locally. So I'm going to then say hackexploit bwap docker. That's going to pull that as well. This is quite large, even better. So that's done. And it's then going to extract. So I'm just going to wait for this to complete here. And once that is done, we can say docker images, and we have the images here. So if we run that again against the Ubuntu image, which for some reason it's not letting me do because we are specifying the arguments correctly. So what we can do is try and run the actual Docker, the actual Trivy Docker image here. And yeah, so that works, and we need to specify the options. So we can say, in this case, we're scanning an image. So we can say image and then specify Ubuntu 18.04. And let's see if that works. That indeed does work. So it's going to download the database here. Once that is done, it should scan that image for vulnerabilities. And indeed, we can see that we have all the vulnerabilities listed here, as well as their respective CVE code. So because this image is so old, you can see that they're sorted, the vulnerabilities are sorted based on their severity. So we have low, medium, and high, as well as critical. And it looks like a majority of them are, have a low severity there. And then, of course, we have a few medium severity vulnerabilities. So the table displayed to you here will essentially will be sorted into various columns. So you have the library or the package that's affected, and then the vulnerability ID, the severity, the installed version, and the version where this was fixed so that you can update that. And then, of course, the title of the vulnerability. So you can see that. Let's see if we can find any of the medium of severity vulnerabilities here. It looks like that's a privilege escalation vulnerability. Medium here again, same thing. And the other medium one here. So again, this gives you an idea as to what needs to be patched. In this case, this still looks relatively safer than other Docker images. So we can actually run this against some of my other images. So I'm going to say Docker images, and the screen might be a little bit small for you, but that's because I want the table displayed fully. So I'll say image, and in this case we can say hackexploit and bwap docker, hit enter. Let's see, it's going to download the database there, and that's the vulnerability database. So we'll give this a couple of seconds. And yep, as expected, this one is going to have quite a lot of vulnerabilities. And you can see that we can actually, we have scrolling not set up correctly here. So I'm just going to head over into profiles and into scrolling. I'm going to set that to infinite scroll back, and we're just going to run this again. So I'll clear out my terminal. There we are. just so that we can see all the output for that particular image there. So I'm just going to let this complete here. And there we go. So we have a high severity vulnerability. Now we're talking. So you can see the sudo package in this Docker image. You can see right over here has the relative CVE code and the severity is high. Now, if I would have just run this Docker image without knowing this, then, I would not, I would essentially be running a vulnerable Docker container that, in the case of this vulnerability, this is a privilege escalation vulnerability. So it's really not that important, but, you get the idea. These are vulnerabilities that could negatively impact your container infrastructure. So let's take a look at some of the other ones here. So these are all low severity vulnerabilities. We have a couple of medium ones here. And as you can see, it performs a check on all the packages or libraries, regardless of whether they're, Linux utilities or libraries, but also, if it is running PHP or the Docker container is utilizing frameworks, web frameworks. So you can see there's quite a few vulnerabilities for this particular image. And in this case, you can see we have a few buffer overflows there. Let's see if we can find a couple more. So we have another high one here. That's really not a remote code execution vulnerability there. And we have a couple of other ones here. So you get the idea. Now, to show you that, in the case of, to actually give you a better example, we're going to be utilizing a Docker image here that is used to essentially set up a vulnerable web application or a web application that is vulnerable to shell shock. So if you're not familiar with shell shock is a family of security bugs in the widely used Unix bash shell, the first of which was disclosed on the 24th of September 2014, and it essentially allows attackers to remotely execute arbitrary commands. So this will be a perfect example to show you how this works. So, I'll just get rid of that there, and we'll say docker pull, and we're going to pull that image there. So there we are. And we can now, specify that we want to run that particular. So I'm going to say we're going to run the Trivy image there as a container. And that is, we are essentially just going to copy the name there. And we'll hit enter. And let's see what vulnerabilities affect this particular Docker image. So there we are. We have quite a few. And let's see if we can identify the shell shock vulnerability. So I'm just going to go through all of these here, and I'll just go to the top here, and we should be able to see the total number of vulnerabilities that affects this particular Docker image. So if we take a look at bash here, we can see that this is the shell shock vulnerability. So this is set to critical, as you can obviously tell, and it tells you what version this was fixed in, so you can actually install that version. So specially crafted environment variables can be used to inject shell commands, and this is critical because this attack or this vulnerability can be exploited remotely. So if this Docker container and the web application hosted within it was hosted or was actually being hosted to serve customers, and an attacker could potentially identify the vulnerability and exploit it, and consequently gain access to your Docker container. So the most important thing to note here is that Docker containers are part of the infrastructure, and as a result, their security or the security of your Docker or containers needs to be taken into consideration, directly or from the actual point where you're actually creating the images yourself. Now, in this case, I've performed scans on images that are not mine, apart from the actual BWAP. Apart from the BWAP image, and in that case I would be able to go through that report, or take a look at all the vulnerabilities within that particular Docker image, and I would be able to fix those or make amendments to the original Docker file. I can then build the new Docker image and run a scan on it again to see whether those patches have been implemented, and the actual process or the cycle repeats itself. So go ahead, you can take a look at the actual Trivy documentation if you're interested in using it to scan for misconfigurations in Git repositories, as well as Docker files themselves, which can also be very, very useful. As I said, all the links utilized in this video will also be provided as an additional resource. With that said, that is going to conclude the practical demonstration side of this video. So in the next video and the final video within this series, we're going to be taking a look at incident response with FireEye Redline. All right, so the actual Redline tool made or developed by FireEye is pretty much one of the best solutions out there when it comes down to incident response and digital forensics. So that is what we'll be exploring in the next video.